So in today's tutorial, we are going to be looking at adding and subtracting fractions. As I mentioned, this is a move on from last week when we looked at converting mixed numbers into improper fractions. This week, we're going to be looking what we can then do with those improper fractions and maybe then converting them back to mixed numbers, because we now know how to do that very well as well. Justin has just joined us. Hello, Justin. Nice to see you. So we'll start with our aims and objectives. So today the aim is to know how to add and subtract fractions, including mixed fractions or numbers. And the objective is to be able to add and subtract fractions with the same and different denominators and also mixed numbers. So as I said, we're going to be looking at adding and subtracting fractions with the same denominator, adding and subtracting fractions with different denominators, and also adding and subtracting fractions that are shown as mixed numbers. So we'll have a quick recap on the mixed numbers as well. So adding fractions then, we'll start with adding. So there are 3 steps to adding fractions. Have we all got pen and paper ready so we can have a go? There's lots of questions for you to have a go at today. I'm going to be putting the maths back over to you because you performed so well last week. You don't need me to go through every single one. Obviously, if I need to, not a problem. But I think you guys are capable of having a go, and obviously you're good at giving me some answers. So the 3 steps to adding fractions. Step 1 is to make sure the bottom numbers, the denominators, are the same. Step 2 is to add the top numbers, the numerators, and put the answer over the denominator. And step 3 is to simplify the fraction if needed. So just a quick reminder at the top, the numerator is at the top of the fraction, and the denominator is at the bottom of the fraction. Okay? So this is an example which I've broken down to begin with fractions with the same denominator. So when we say the same denominator, it means if we're adding 2 fractions together, both the denominators, the bottom numbers, are the same. So in this example, we've got 1/4 plus 1/4. So step 1 is on the left. Make sure the bottom numbers, the denominators, are the same, which they are. Step 2 is to add the top numbers, the numerators, and put the answer over the denominator. So 1/4 plus 1/4. We'll do 1 plus 1 to give us 2, and we put it back over the denominator, 4. In this case, step 3 is to simplify the fraction if needed. So we've got 2 over 4, which we can simplify to 1 over 2, because 2 goes into both 2 and 4. And when we simplify a fraction, we're looking at finding the lowest common denominator, which is the number that appears the first time in both of the multiplication tables for 2 and 4. So the first number that appears in both of those, or 2 goes into both those, that's another way of doing it. So 2 goes into 2 once and it goes into 4 twice. So we can simplify that by turning 2 over 4 into 1 over 2. Right, so can't see the presentation. Oh, this is going so well today, isn't it? Already, it's showing aims and objectives, presentation is moving on. Right, let's see. Has it moved now at all? What can you see on the screen now? Yeah? Did it just need a little kick up the bum? What page can everybody see? Can you see slide 4 with the examples, same denominators, and you've got some blue arrows? Yeah, can everybody see that one? No problem. There's always technical issues when we're using technology. We're quite prepared for them. We do not panic. We just move on. So there we've gone through an example of adding fractions with the same denominator. All we do is add the top, the numerators, put it back over the denominator, then simplify the fraction if needed. So there's our 3 steps in quite a good example there. And what I've done on the next page is showed you that with an image, because some people find it much easier to understand as an image. So we had 1/4 plus 1/4. We always use pizzas or pies for fractions. So 1/4 plus 1/4 is 2/4, which we know is a half. We can see it there as a half, but we can simplify the fraction 2 over 4 and turn it into 1 over 2. Okay? So I've got another example for you here. So step 1, we've got 2 over 9 plus 5 over 9 this time. So step 1, make sure the bottom numbers, the denominators, are the same, which they are. Step 2 is to add the top numbers, the numerators and put the answer over the denominator. It's not moving again, is it? Shall I just slow down? What page can you see at the moment? Can you see the pizzas? Right, we're having a bit of issue here. What page can you see at the moment? Still on the same denominator. So I actually showed you pictures of pizzas. I must have sounded really crazy. Right, so some of you can see slide 6, which is the one that we're on, and some of you aren't quite there yet. Let me just jog it on again. What about now? Are we on slide 6? Right, you can all just see, a few people that could have seen 6 a minute ago can now see 5, and I went back to 5 and then back to 6, so there's definitely a delay here. But it's not an issue. What I can do if it really is delayed is I can just start writing it on the screen instead so we can all see the same thing. What we can do, I'm going to keep it on slide 6 because yours might end up catching up. And what I'll do, I'll write everything on the board just for people that can't see slide 6. And I'll keep telling you what slide we're on. Is that okay? So we're on slide 6. Slide 6 is an example of adding fractions with the same denominator. And the example is 2 over 9 plus 5 over 9. Okay. And all I've got is the 3 steps on the left hand side as well. So step 1 is to make sure the bottom number of the denominators are the same, which they are in this example. Step 2 is to add the top numbers, the numerators, and put the answer over the denominator. So all we would do is add these two to give us 7, and we put it back over the denominator, 9. It then says simplify the fraction if needed, which is step 3. And then simplify the fraction if needed. Can we simplify 7 over 9 at all? A few people are saying the chat box is slow as well today. Don't worry, I won't be offended if you're not sort of talking to me. I know that it's not really working. It's going very slow today. I apologise. I'll keep trying to speak over everything that I'm doing, okay? Right, we will not let technology defeat us today. I've got a cold, it can't get any worse than this. So no, we're correct. The majority of people said we can't simplify 7 over 9. So that is the answer here. And it's as simple as that, particularly when your denominators are the same. So 2 over 9 plus 5 over 9 is 7 over 9. We can't simplify that any further. Okay. So I'm going to move on to slide 7. Now, slide 7 has a few examples. It's got 5 examples for you to have a go at. Because as I said, I'm going to pass the book over to you a little bit today. I'm going to read out the examples. So if you want to have a go, you can write them down in case you can't see slide 7 at the moment. So we've got 5 over 8 plus 1 over 8. We have 3 over 7 plus 2 over 7. We have 5 over 9 plus 3 over 9. We have 4 over 12 plus 7 over 12. And I'll have to put the other one here. We have 3 over 6 plus 7 over 6. So just in case anybody can't see it, I'm hoping you'll be able to see that. Let's just move that up a bit on the screen. So you might be able to chat me back, you might not. The first one is 5 over 8 plus 1 over 8. The second one is 3 over 7 plus 2 over 7. The third one is 5 over 9 plus 3 over 9. Then we have 4 over 12 plus 7 over 12. And then 3 over 6 plus 7 over 6. Fab, Tasneem's got an answer for the first one. Can you simplify that, Tasneem, now at all? Step 3, simplify the fraction if you can. In an exam, you'd always simplify the fraction unless it asked you not to, or if it gave you maybe the bottom part of the fraction and it was obvious it wasn't simplified, for example. Fab, well done. So 5 over 8 plus 1 over 8 gives 6 over 8, and we can simplify that to 3 over 4. Because we can divide 6 by 2 and we can divide 8 by 2. That gives us 3 over 4. So what about 3 over 7 plus 2 over 7? Yep. 5 over 7. Can we simplify that at all? No. No, because there's nothing that goes in both 5 and 7. We can't make it any simpler than that. 5 over 9 plus 3 over 9. Yeah, well done. We've got 8 over 9 because we've done 5 plus 3 is 8. Back over the denominator 9. Can we simplify that at all? No, there's nothing that will go into both 8 and 9. 4 over 12 plus 7 over 12. What did we get? Yeah, well done everyone. 11 over 12. Can we simplify that at all? No. No, that's right. I seem to be getting some chats through, which is good. So if yours isn't coming through, don't worry at all, because I can still see a few people's as well. We've got 3 over 6 plus 7 over 6. What did we get for that? Yes, so this one, I chucked in at the end because it is it's a top-heavy fraction. It's an improper fraction. So everybody's right, and we've all done the different thing, which is not an issue at all. We've got 10 over 6, which we can then simplify to 5 over 3, which is fab. But we can then convert that 5 over 3 into a mixed number because it's a top-heavy fraction. It's an improper fraction, just like we did last week. So we could do that. Obviously, we don't have to. But if we were to convert 5 over 3 into a mixed number, what would we get? Yeah, and Pam's just pointed out, which I've done the same. Pam turned it to a mixed number from this one, which is fine, or this one. So we've simplified it. When we simplify this, we got to 5 over 3, which if we turn into an improper fraction is 1 2/3, because 3 goes into 5 once with 2 3s left. Now, if we turn it into an improper fraction, a mixed number from here, we end up with 1 4/6, which technically you could simplify that to 1 2/3. So it's exactly the same. It doesn't matter when you do it, you could end up with the same answer. You could simplify 1 4/6 into 1 2/3. It's the same. Is that okay? Any questions on that at all? Yeah, fab. Like I say, if anybody's chats aren't coming through, don't panic. It's not a problem. I can still see most people. Pam says she can't type anything. I'm getting your chats, Pam. I don't know if anybody's finding that. I've got 2 from Pam that say the same thing, so they might still be coming through to me, even if they look like they're not to you. So I'm not sure why, but I am getting the responses from everybody. I think from most people. Right, we're going to move on to slide 8 now, which is different denominators. So we've got an example on the screen of a fraction to add with different denominators. We're on slide 8, and the example is 1/2 plus 1/3. So if we use the 3 steps that we went through in the beginning, step 1 is to make sure the bottom numbers, the denominators, are the same. In this case, they're not. So what we have to do is we use equivalent fractions to make them the same. We find a common multiple. So what's the lowest common multiple of both 2 and 3? Which number appears in their multiplication tables first from both of them? In 2 and 3, we end up with 2, 4, 6, 8, 10, or 3, 6, 9, 12, 15. So the first one that appears in both 2 and 3 is 6. Fabulous. Well done, everyone. So what we can do is turn both the denominators into 6. So sometimes I like to just write it out like this as the next step. Some people do, some people don't. It's absolutely fine. But what we then need to do is figure out what we would have done to 2 to get to 6. We have to multiply it by 3. So what we do to the top bottom, we also do to the top. So 2 times 3 is 6. 3 times 1 is 3. So we end up with 3/6. For this one, we've turned 3 into 6. So to get 3 into 6, we have to multiply it by 2. Because we've multiplied the denominator by 2, we multiply the numerator by 2 as well. So we end up with 3/6 plus 2/6. Fab, well done. Now we have both denominators the same, we can then carry on with the next step. So step 2 is to add the numerators and put it back over the denominator. So in this case, we could do 3 plus 2 is 5. I'll put it back over 6. So we end up with 5/6. So 1/2 plus 1/3 is equal to 5/6. Is everyone okay with that? Any questions? Fab. I'm going to move on. I think everybody seems to be okay. I apologise if I'm not seeing a chat, but I think I'm getting them, so it's not a problem. So Chloe says the first bit's okay. Are we okay with changing the denominator to the same number? I'm pretty sure I've got another example next. I'm going to show you. Yeah, I have. Yeah, okay. So we've got another example here again. I won't waste paper because that's a bugbear of mine. Fab. So I'll just do this other example just to make sure everybody's okay with it. So this time we've got 1/3 plus 1/6. So step 1, make sure the denominators are the same. In this case, they're not. So we need to find the lowest common multiple, or in this case, you'll find the lowest common multiple is one of the numbers. So if we use the 3, 3, 6, 9, 12, or 6, 12, 18, 24, etc. So the lowest common multiple of 3 and 6, sorry if you can't see that, might be too high, is 6. So we're going to change the denominators so they're both the same, and in this case it will be 6. So again, I'm going to set it up for myself. One of the denominators is 6 already, so we don't have to do anything to that fraction. We could just set that up to be the same. The only one that we have to change is the 1/3. So what do we do to 3 to get to 6? We multiply it by 2. Because we multiply that by 2, we multiply this by 2 as well. We multiply the numerator by 2. So 2 times 1 is 2. So we end up with 2/6 plus 1/6. Step 2 is to add the numerators and put it back over the denominator. So we end up with 3/6. Can we simplify that for step 3? We can simplify 3/6 to get 1/2. because 3 goes into 3 once and 3 goes into 6 twice. So we can divide both by 3. Hopefully you'll get to a stage with fractions where you can see these sorts of things. 3 over 6 is equal to a half because 3 is half of 6 as well. Fab. Well done. So I've got some examples for you to have a go at. What I've done this time, because this is a little bit more advanced, obviously there's an extra step there, is I've added 6 examples. Now the examples on the left, they already have some parts to it. If you're doing level 1, you might want to look on the left. If you're doing level 2, you might want to do the right-hand side. But if you want to have a go at all of them, feel free, it's not a problem. Can everybody see slide 10, or do I need to write this out on the board? Are you all okay? Can we see slide 10? Yep. If I need to write it out, I can just say it for you. So Georgie can't see it. That's not a problem, Georgie. I can read it out. So I'll give you the 3 on the left, Georgie. So if you want to write these down, Chloe can't see. Okay. So what we'll do, if you just pick 3 to do, left or right, then I'll go through them. So we have 1 over 3 plus 3 over 6. I'll try and write these out. There's not much space on here. How far can I go? 1 over 3 plus 3 over 6. And we have 1 over 5 plus 4 over 15. Then we have 2 over 7 plus 5 over 14. They're on the left. On the right, we have 4 over 30 plus 3 over 10. We have 6 over 28 plus 3 over 4. And we have 2 over 5, you see that still, plus 8 over 25. Does anybody want me to read any of those out again? Let me know when you're ready to go through any of them. And give a few minutes, obviously. Right, is everybody ready to have a quick go at some of them? Don't worry if you haven't done them all. We can go through them. We've just got quite a few other things to cover today as well, that's all. So does anybody have an answer for 1 over 3 plus 3 over 6? Yep, 5 over 6. So lowest common multiple, or number that will go into both, 6 is in both. So we don't change the second one, we just change the first one, the 1 over 3. We turn that into 2 over 6. We then add the top and put it back over the bottom to get 5 over 6. Fab, well done. So 1 over 5 plus 4 over 15 this time. Yeah, well done, everyone. We've got 7 over 15 there, because 15 appears in both the 15 times table and the 5 times table. So we can keep the second fraction, as we did. We'll just change the first one. So we turn 1 over 5 into 3 over 15, because we multiplied the 5 by 3 to get to 15 to make it the same as this one. Then we multiplied the numerator by the same amount by 3 to get to 3 over 15, and then added the top and put it back over the bottom. 2 over 7 plus 5 over 14. Any takers for that one? Yeah, well done. 9 over 14. Is everybody else okay up to now? Fabulous. So now we've got 4 over 30 plus 3 over 10. I'll just do the maths behind you whilst you're working that out. Yeah, I've got 13 over 30 there. Did you get that, Tasneem? Sorry. So we've got 30 and 10. So 30 appears in both. We can keep the 4 over 30. We just need to change the second fraction, 3 over 10, to make that numerator match. So we've multiplied the 10 by 3 to get to 30. So do the same with the top to get to 9 over 30. We add the top to get 13 and put it back over the bottom, 13 over 30. We've then got 6 over 28 plus 3 over 4. Any takers for that one? I'm running out of space here. Any answer for this one? 6 over 28 plus 3 over 4. Gosh. This is where my cold comes in, because I've just sat and looked at it. Oh my word. I've got a few different answers for that one. Blimey. So 27 over 28. Sorry, guys. I knew it was going to pop in there somewhere. 27 over 28. So 28 is 7 times 4. So we keep the 28, 6 over 28. We multiply the 4 by 7 to get to 28 as well to match. So we multiply the top by 7 as well to get to 21. Add the top, 21 plus 6 is 27 over 28. Fab. Well done. Last one, 2 over 5 plus 8 over 25. Let's see if my brain's working this time. Yeah, fabulous. 18 over 25. Well done. Right, is everybody okay with adding fractions? Any questions? Fab, Chloe feels better on that now, which is exactly what the aim of today is, which is great to hear. So I've now moved on to slide 11. We're going to stick with adding, and then we'll move on to subtracting shortly, because there's not much difference between the two. So adding mixed fractions this time. So anybody that didn't attend last week's tutorial, I probably would have sent you the recording anyway if you requested it. So we're going to look at adding mixed fractions. So this is literally taking on what we did just last week and moving on to what we can do when we convert a mixed fraction. So I'll just briefly go through this example on the board, just in case anybody wasn't there last week and we're not sure how to convert a mixed fraction. So if we have to add two mixed numbers, which is a fraction that has a whole number, a number that has a whole number and a fraction with it. Anybody who was here last week, please feel free to have a go, work your way through and see what you get. So if we're faced with this, we need to convert these mixed numbers into improper fractions first. An improper fraction is a fraction where the top is heavier than the bottom. So we do that by multiplying the numerator by the whole number. So 4 times 2 to give us 8. We then add that to the denominator by the whole number, and that multiplied by the numerator. We add the numerator to that to get 11 over 4. We do the same with this one. So we take the denominator, multiply it by the whole number. So 3 times 2 is 6. We then add the numerator to give us 7 and put it back over the denominator. Okay, let me check my maths there because I'm really not trusting myself today at all. 6, 7 over 2, 4, 8, 9, 11 over 4. So what we've then ended up with is what we've just been talking about, which is two fractions that have different denominators, but we need to add. So all we do then is change the denominators so they both match. So I'm going to swap this one because 4 appears in both times tables. So I'm going to stick with 11 over 4. And I'm going to convert this one and turn the denominator into 4 as well. So we multiply 2 by 2 to get to 4. So we do the same with the top. And that will give us 14 over 4. We then add the numerators to give us 25 over 4. Did everybody else get that as an answer? Or have we all gone ahead and converted it back into a mixed number, which is fabulous if you have. So what we can then do with 25 over 4, let me get a different colour. As we're recapping from last week, we can then recap. I can see what Pam's. I thought Pam had wrote 61 over 4. I thought, where on earth? But she says 6 1/4. Sorry, Pam. So what we do then, if we've got an improper fraction, we can convert it back into a mixed number. So a number that has a whole number and a fraction. We do that by figuring out how many of these denominators go into the numerator. We can even write it out. So 4 goes into 25, 1, 2, 3, 4, 5, 6 whole times. With 1, because there's 1 left between 24 and 25, 1/4. So well done if anybody did that, recapping from last week, which is fabulous. So we have 2 3/4 plus 3 1/2 equals 6 1/4. I think. No, I didn't do that. It's fabulous. Any questions on that? Are you okay with that? Or do you want me to go over converting them again? Brilliant. Right, George wants to have a go again. It's not a problem whatsoever. So we have 2 3/4 plus 3 1/2. They are mixed numbers. So to be able to turn it into something and regular fractions that we can recognise and we can actually add, just like we've practiced a minute ago, we're going to convert the mixed numbers into improper fractions. So we do that by taking the numerator. So in this 2 3/4, that's the 4. We multiply that by the whole number. So 4 times 2. If we go in a circle, we make sure everything's done. 4 times 2 is 8. We then take the result of that and add it to the numerator to give us 11. we put it back over the original denominator. So 2 3/4 turns into 11 over 4. Okay? We'll do the same with this one. So the numerator is 2. 2 multiplied by the whole number, 3, gives us 6. 6 added to the numerator. So 6 plus 1 gives us 7. And we pop that 7 back over the original denominator. So 3.5 turns into 7 over 2. We then start with those 3 steps that we've just been going through about adding fractions. So we then end up with 2 fractions that have different denominators. We then find the same denominator. So looking at both 4 and 2, 4 appears in both the 2 and the 4 times tables. So I'm going to stick with 4. So we keep 11 over 4 the same, but I'm going to turn 2 into 4. To do that, I'm going to need to multiply it by 2. Because I've multiplied the denominator by 2, I'm going to multiply the numerator by 2. So 2 times 2 is 4, and 7 times 2 is 14. So we end up going from 11 over 4 plus 7 over 2 to 11 over 4 plus 14 over 4. Now our denominators are the same. We can then go to step 2, which is adding the numerator. So 11 plus 14 gives us 25. And we put it back over the denominator, which is 4. So we then have 25 over 4. We then can convert that back into a mixed number by figuring out how many 4s go into 25. So how many of the numerator goes into the denominator. There are 1, 2, 3, 4, 5, 6 whole 4s in 25 because we can get that up to 24 in the 6 times table. So there's your whole number. There's 6 whole 4s. And the difference between 24, which is how far we got up to, and the number we're aiming for is 1. That leaves us is 1 4 or 1/4 or 1/4 left. So the answer to 2 3/4 plus 3.5 is 6.25. Is that okay? I've got another example for you to have a go at. Brill. So hopefully, I'm going to put this on the board. Slide 12. We've got a question. I'm going to let you have a go at this. I'm going to have somebody explain how you did it as well. 3 5/8 plus 1 3/4. So if you want to have a go at that, let me know when you're ready. And if you want to explain, well, try to explain the best you can, I suppose. Like I said, I can give anybody mic access if they want it. I'm going to do it on my bit of paper so you can't see my workings out. Pam and Maria are on fire. I actually think that you did that quicker than me. Well done. If anybody's still going, just don't look at the chats because the answers could appear. Well done, Kim. Right, I'm going to start going through it. I'm only thinking about, oh, well done, Tasneem, time. Now, if you're doing a level 1 qualification, you probably won't be faced with a question like this. I've got a couple of examples from practice tests for you to see as well at the end. If you're doing level 2, you could be faced with this. So don't worry if you haven't quite got it yet. It's not a problem. Plenty of time. So I'll go through it quickly. Just see if you did the same thing. So I'm going to convert these mixed numbers into improper fractions. So 8 times 3, 24. Plus 5, 29. Back over 8. 4 times 1 is 4. Plus 3 is 7. Back over 4 is 7 over 4. So I've then got 29 over 8 plus 7 over 4. Now I've got fractions that have different denominators, so I'm going to turn them both into 8 because 8 appears in both the 8 and the 4 times table. So I can keep that one the same, but for this one I'm going to multiply the 4 by 2 to get to 8, so I'm going to multiply the 7 by 2 as well to give us 14 over 8. So 29 over 8 plus 14 over 8 is 43, sorry, over 8. I'm struggling today. Fab. Thanks, Pam. She's really ready for me. So I've ended up with 43 over 8. Now I can turn that back into a improper fraction. Oh, sorry, a mixed number because it's an improper fraction at the minute. How many 8s go into 43? So 8, 16, 24, 32, 40, 48. 1, 2, 3, 4, 5 whole 8s in 43. And 3, the difference between 40 and 43 is 3, 5 and 3/8. Fabulous. Brilliant. So, well done everybody for that. We can move on to subtracting now. Now, I'm going to go through it, but it's very, very similar to adding. We use the same method, but instead of adding, we subtract. So we're on slide 13. Kim's saying, would I simplify if I could? Sorry, Kim, just caught that chat. You could simplify here if you could. You could simplify here if you could, but I'd be quite happy with that as an answer, I think. I mean, you can't simplify that anyway, but yeah, if you simplified here, you could still turn it into a mixed number, which would still be the same. Because remember, there's lots of fractions that are equal to the same amount. They're just shown in a different way, different amounts of numbers, but they mean the same. So yeah, you could simplify. You couldn't really simplify those, but yeah, absolutely. But you'd still end up with a similar one. You'd still end up with that. And I think in your exam, you would probably end up with a scenario like this where you maybe wouldn't be able to simplify. You would just convert back into a mixed number if it asked you to as well. So subtracting fractions. There are 3 steps to subtracting fractions. Make sure the bottom numbers are the same. Oh gosh, I've left add in there. Subtract the top numbers. Sorry, you guys have actually woken me up a little bit today doing this, but it's not been the best week. Subtract the top numbers, put the answer over the denominator and simplify the fraction if needed. So let's have a look at an example. So we've got 3 over 4 minus 1 over 4. So the denominators are the same, just like we did with adding, which we've already proved we can do. We just subtract from the numerators. So 3 minus 1 to give us 2. And we put that back over the original denominator because it's the same. 2 over 4, we can then simplify, which is step 3, and turn that into 1 over 2. Well done, Pam, thank you. Is everybody okay with sort of going quite swiftly through the simplifying, this section, sorry, the subtracting, only because there's a couple of examples I want to show you at the end. So if you want to have a go at those, you can do. Yeah, so if we just have a look at on the screen, obviously if anybody wants to have a go, I'm going to send you the recording anyway, so you can go through it at your own pace as well, as we always do. So 10 over 12 minus 3 over 12, the denominators are the same, so we don't do anything with that. It's back over 12, and we just subtract the numerator. So 10 minus 3 is 7, so that gives us 7 over 12. Just the same for the next one, the numerators are the same. So we stick with 8 because it's the same. We then subtract the numerator, sorry, 7 minus 6 is 1 to give us 1 over 8. 6 over 10 minus 5 over 10. Oh, Chloe can't see the slide. Don't worry, I will send you the recording, so obviously you can go through it at your own pace as well, guys. I'll keep talking over what you can see as well. So the next one is 6 over 10 minus 5 over 10. There's just 4 examples on this screen, this slide 15. So the denominators are the same, so we stick with 10, then we just subtract the numerator. So 6 minus 5 is 1 to give us 1 over 10. Left, fab. And then we've got 4 over 6 minus 1 over 6. So numerator's the same, put it back over 6 and we just subtract the numerators. So 4 minus 1 is 3 to give us 3 over 6. Obviously we could then simplify that to 1 over 2. We could divide both by 3. Fab, well done. So let's have a quick look. I've got a subtracting mixed fractions example here, or a couple. We'll just have a go at one or two of those. I know the time's ticking away a little bit. So we've got, just in case you can't see it, I'll write it on the board, 3 2/5 minus 1 1/5. Do you want to have a go at that one just for a minute? I'll do the same. What did we get? See, I've not got that, but I'm not trusting myself today, if I'm honest. 17 over 5, 6 over 5. I've ended up with 1 1/5. Pamela's now got 1 7/5. Kim's got 11 over 5. We've all ended up with different answers here. Right, let's work it. Do tell me if I'm doing something wrong here, because literally my brain's it's frazzled. Right, so 5 times, let's turn them into improper fractions first. 5 times 3 is 15. Plus 2 is 17. Back over the numerator 5, so 17 over 5. Yeah? Oh no, I can see where I've gone wrong. 2 1/5. Do one of you guys want to come here and do this today? And I'll join you. So we've got 5. 5 times 1 is 5. Plus 1 is 6 to give us 6 over 5. And this is where I went wrong. This bit. How silly. 17 minus 6 is 11, not 9. 11 over 5. We can then convert that, because these are now the same. Anyway, we ended up with it. We started with the same denominators. 11 over 5, so 5 goes into 11 twice, plus 1 left over. 1 over 5 left. Maria's on page 17. Don't worry, Maria, we're going to do that in a minute, but we will be there. You can still do it. We'll do that next. So here's one more example. Let's see if we can see if I can manage this one. 15 3/4 minus 8 5/6. Everybody want to have a go? I'll set the countdown clock. Tick tock, tick tock. Yeah, Maria, we're doing 5 3/4 minus 8 5/6, the one that I've put on the board. Is that okay? Right, I have an answer. I'm hoping it matches yours. Sorry, guys. Has anybody else got one? Yeah, that's right for step 1, Chloe. What you need to do, yeah, let me go through that. Yeah, I can go through the method for this one. This one's got much bigger numbers in it, which is probably going to take a little bit longer. And obviously, if we do one little step wrong in that multiplication somewhere, it's going to throw us off completely. So let's go through this one together. So let's use a different colour. 15 3/4. So we're going to convert that first into an improper fraction. 4 times 15 is 60. Put that back over, add the 3, gives us 63/4. We'll convert this one next. So 8 times 6. Oh, sorry. 8 times 6 is 48. 53. Yeah, 53/6. What we then need to do is make the numerators the same. So the lowest common multiple of both 6 and 4 is 12. So we'll turn this into 12 first. So to get from 4 to 12, we need to multiply by 3. So we multiply 63 by 3 to get 189. To get from 6 to 12, we need to multiply it by 2. So we'll multiply that by 2, we'll multiply this by 2 to get 106. So we end up with 189 minus 106. Let me go through. So 189 minus 106 will give us 83. 83/12. 83/12. Everybody okay with that? We can then convert that from an improper fraction, 83/12, into a mixed number by figuring out how many 12s there are in 83. So 12 times 6, I know, is 72. So I ended up with 6 and 11 12s. So 12 times 6, 72, which gives us 6 whole and 11 twelfths left. Did anybody else get 6 and 11 twelfths? Yeah, we got that. See that the method's just the same there. It's just the numbers were so much bigger. It took us a little bit longer to get there. But sometimes if you had a cracking question like that, that would be worth a few marks. To be honest, in an exam, you might even get that and then get some different scenarios, like a multiple choice question answer. So even if you got close, like Tasneem got really close, you might then find that you're probably the closest to that answer, which will give you the right one. So 16, 11, 12s. Well done, Maria. Would this be non-calculator, Kim said. It could be, to be honest, because I did that without a calculator, so it is not impossible. So let's just move on very quickly now, because I know we've been on it a little while. So level 1 maths non-calculator example this is. So I'm not going to go through this, but on the recording, when you get it, if you want to do it, you can. Just to give you an example, so level 1 maths non-calculator example. So 5 and 2/5 is the same as, and that's a good example of what you get at level 1. So you've got the answer over 5. So they've even given you what it is over 5, and you just have to put your answer in the box there. So 5 times 5 is 25 plus the top will give you the answer you need. That's just worth 1 mark in a level 1 maths non-calculator example. So that is non-calculator. Here's a level 2 maths non-calculator example. So this is a good example of what I was just saying. Even if you didn't quite get there, or quite often in these scenarios you get multiple choice answers. So if you're very, very close to something, the chances are that's the answer. But this again is worth 1 mark. So you've got a whole calculation to do. You've got 2 mixed numbers which you need to add together. So you're going to convert them, add them, convert them back. But you do get multiple choice. So even if you're running out of time and you're not quite sure, you've got an extra little bit of help hopefully there in your non-calculator example. Okay. So you can work through that if you want to at your own time. I'll send you a recording of this tutorial as well. So that's the end of today's tutorial. Thank you very much. I'm just going to stop recording now.